So dimension is one integrated which talk about one subject area, like customer dimension, one subject area is customer, product dimension, one subject area is product. Ideally, it should be like this. So star schema, as its name indicate, it look like a star and there is one dimension table surrounded by fact table and each fact table is denormalized. Assume this is my model. I just join these two fact tables. Just imagine, and this is my model finally. This is my model finally. Now imagine this is one fact table. So there is one fact table surrounded by a dimension table and each dimension table is denormalized. So fact, the most important about star schema, most important aspect is each dimension is denormalized and has no branches. Each dimension table is, there is one instance of each dimension table and has no branches, which is not, this is my star schema. One fact table surrounded by dimension table. The star schema is designed with certain purpose. Limitation in one line, if you write limitation, it does not design for insert and update operation. Therefore, later on we'll talk about this model doesn't suit for planning and budgeting application. Planning budgeting application. What is the advantage? The biggest advantage, the model is simple and designed to speed up query performance. Okay. Fundamental is the less join you have, the faster you can access the information. So let's take an example. Okay, example 1, scenario 1. In this scenario, my customer information is stored like this. I need to identify customer information, right? Customer information is stored in these tables: customer address, customer postal address, customer contact details. This is my transactional model. Customer geography, where does customer customer ethnic type and customer history. These are all tables, and we have one fact table called sales, fact sales. So in order to fetch customer details along with the fact, how many tables we need to process? 1, 2, 3, 4, 5, 6. 6 tables. There would be 6 joins to 6 number of tables minus 1. There should be 5 joins to process the record, right? So when you write a select query, column 1, column 2, customer name, customer 2, blah blah blah, from how many tables? These tables. all 6 tables you write. Where then you apply join customer address dot customer ID. I assume customer ID is a common key. ID equals to customer contact detail dot customer ID. Right? This is how you need to write a query in order to process it. So query becomes so complicated and it takes more time to process. The more join you have, the more time is required to process the query. This is example 1. Example 2, what I did, I denormalized all the customer table into a common table. Now in second example, I've got customer cust all, dim cust all, dimension customer all information. I denormalize and put all the customer table information to common table. So I've got one fact table. Now my query would be, there would be only 2 columns. Dim cust all, comma, fact, sales. So there would be only 2 join. So simple fundamental is that we go back to fundamental database. Why do we do normalization? We do normalization in order to manage, insert and update and delete anomalies. The transaction model is designed for insert operation or update operation. Therefore, normalization is required. Whereas in multidimensional database or data warehousing need, business intelligence, we generally require data, we generally fetch the data, retrieve the data or create a report. So we need a select queries. So in simple word, from normalization, you go towards denormalize, when you go towards this, you improve select query performance, you go toward that and get high level of duplicate records. The more you go to normalization to denormalization, higher number of duplicate records, and the more you go towards denormalization and insert, update or delete anomalies. Whereas the other way around, the more you go from to denormalization to normalization, what do you do? If you denormalize, normalize, denormalize, slow query performance, few duplicate records, and designed for insert, update and delete operations. So in my example, in the transactional table, there was 5 or 6 customer tables which I denormalize and make one customer dimension. The complete process of converting multiple transactional table to single dimension table is called data modeling and dimension modeling. Data modeling is the process of identifying the business data and organizing them into the way that it supports the transactional system. Dimension modeling is the process of converting various tables in terms of dimension so that organization of data can be managed prudently. So that is your star schema. Star schema, the biggest advantage of star schema is fast to process. Identify business process for analysis. Business process for analysis, I mean, you know each item maintain one subject area, customer, time, country. Identify measures of a fact. So first you identify dimension, then you identify facts. Identify dimension for facts. Intersection for dimension fact brings certain meaning. Okay. In a star schema, every dimension have a primary key. Every dimension has a primary key. Okay, customer ID, product ID. In a star schema, a dimension table will not have any parent table. There is no parent-child relationship. I'll show you another model where the data is organized in terms of where data is normalized. Okay, this is a pretty difficult model to understand. Let's see this way. In this example, I have got one fact table and two dimension table, store and time. Now store dimension table is further normalized into region. Ideally, if I do denormalize, this should be like this. This is my dimension table called store, which I normalized to two tables. This is denormalization, this is normalization. So if what it means, it has no parent. There is no parent-child relationship in the star schema. There is only one table for one dimension. Hierarchy and attribute we'll talk about later. So that's we discuss about today. We'll quickly recapitulate. I'm stopping over here. We discuss about today the need of multidimensional database. We also discuss about what is dimension, facts, and what is the business meaning of it. We also discuss about advantages of organizing data in terms of dimension and facts. And discuss about star schema. We'll continue the discussion tomorrow also, and we'll discuss about snowflake, we'll discuss about multi-dimensional database operations, and the most important thing, how to correlate the business requirement. The first step is people learn tool. They just learn tool. They don't try to learn things. Try to learn the tool with business requirements. We'll try to correlate the business requirement with data model. We'll do one real-time data modeling which we receive from one of our POC. We real-time convert from transactional model to OLAP model. This is what we are going to discuss tomorrow. Apart from this, there are certain terms which I have not discussed about data warehousing fundamental, which we are running short of time. So I'll share the video tutorial of what is data warehousing, why do we need it, fundamentals and terms. I'll share the video tutorial, so it's a pretty easy affair. If you're new to data warehouse, you can go through them and get some basic idea about it. So all the terms we are going to use subsequently, it won't be a Greek for you.